Okay, actually I decided I'm only going to really make two videos here. Um, Again, horizontal lines and vertical lines, hopefully that's pretty self-explanatory. Well, the vertical lines, you just have to indicate the range. Again, look at the back of the handout. Look at that M1 on the back of the handout here. Again, you need to indicate the range that I'm looking at. So this is x equals -3. That's that vertical line right there. That's x equals -3. And then the range is from -3 to 4. Horizontal lines, very similar. Please note that on your calculator, you can't really graph vertical and horizontal lines very easily. Actually, not very easily. You can't draw a vertical line because it's not a function. And the horizontal lines, I don't know why, but on the TI-89, it doesn't work where you can restrict the domain. So, but those are easy to visualize. So, again, maybe using your calculator is not the best choice here. But what I would do here is, if you can, maybe you can graph the parabolas and the square root functions on your calculator. I'm just going to do a parabola right now. Square root function is very similar. So we have to remember when you're looking, if you wanted to draw a parabola, you have to remember that your standard function, the standard equation for a quadratic function, the standard form for a quadratic function, sorry, is okay. So that's our standard form for a quadratic function there. H and K, again, is the vertex, whether it's the top or the bottom. A sort of tells you, again, what the steepness of your graph is. This time it's going to be important to really understand what A is in this case. When I'm doing this project, I would only use an A of -1 or 1 if you're feeling a little bit more adventurous and you can graph it more cleanly, and you understand the project a little bit better, then you can use an A that's not 1 or -1. But for now, I'd probably just use an A of 1 or -1. Here I'm going to do an A of -1. Let's see. Let's pick a vertex that's in the first quadrant here. So let's just use how about 4 and 1. So I'm starting to get it, and then my A will be, let's make my A -1. So let's call this capital F sub 1 of x equals 1, so I don't need it. It's x minus, and then that's the x value again, 4 squared plus 1. So remember, again, when we've talked about this, it just means you're shifting the graph over 4, right, because it's inside the function, and then you're going up 1. But now I'm going to have it with a negative, so it's going to be upside down. Or negative on the outside reflects it over to x-axis, so instead of looking like this, it's going to look like that. So let's go ahead and, so again, the negative now. So it's going to start going down. Now, you want to maybe plot some points to get some idea here. But another way there's a couple other ways you can start looking at this problem here. I'm gonna tell you at least a trick that I know is that if it's negative, if I know this is -1, I know, so this is the vertex, but then what I'm going to do is I know that these 2 points exist on my graph. How do I know that? Because it's -1. Well, another way to look at it is like it's my slope. I go down 1 over 1, down 1 over 1. And now the pattern goes that the next one is over 1 and down 3, and then it would be over 1 and down 5. So what happens is it's like every time you go over 1, it's like you're increasing it by 2, if you can sort of see what I'm saying, instead of just increasing a constant amount. So we'll talk about that in chapter 11, actually. That's called a second difference. Maybe you learned that in pre-algebra a little bit. But here, so I'm going over 1, down 1, over 1, down 3, and then over 1, down 5. Over 1, down 1, over 1, down 3, over 1, down 5. So that's what my graph looks like. Now if your a value changed some, now then these values would change a little bit too. But again, you can mess around on your calculator if you really want. Shouldn't, it doesn't hurt to take a couple more minutes to really grasp that idea. But again, I'm just using a -1 for my a here. So this is what the parabola looks like. Now how else could you find these points? How else could you find these points? Well, I mean, you could just substitute x values in, right? So let's say I put in negative or +3 for x. So if I put in +3 for x, 3 minus 4, that's -1. -1 squared, that's +1. Well, we have a negative on the outside, so that makes it -1, and then +1, oh, that's 0. So there you go. So we got that point right there. Same thing here, right? If it was 5, 5 minus 4 is 1, 1 squared is 1, negative on the outside makes it -1, +1 is 0, and so forth. Okay, so just put in substitute values. Get yourself, comfortable with what you're doing here. Don't just, try to skimp on what you're doing. Take a couple extra minutes to understand what's going on. Now let's restrict the domain. So let's say you're trying to draw this, and you can see this sort of looks like an A, right? So again, that might help you for people who are drawing that. But let's say you want to just restrict this portion right here. You want just this. We don't want this portion right here. So you can sort of see the whole A right there. So again, just look at the minimum x value and the maximum x value. So what's my minimum x value here? My minimum x value is 1, 2. So my minimum x value is 2. And my maximum x value is 1, 2, 3, 4, 5, 6, and that's where it ends. So the maximum x value is 6. So that is how you restrict the domain on these problems. Now think about the range. Again, you can just visualize it now. So what's my minimum y value here? It's -3, and my maximum y value is 1. So that's my range. My range is from -3 to 1, both with brackets. Hopefully this helps. Again, if you have any other questions, please post it on the YouTube video, or please post it on Edmodo. And don't be afraid to do so, and pass this along to anyone who thinks, or you think that they need the help because they were gone on Friday. Again, well, just don't text me or call me about it. Okay, that goes for a couple of you. So do not text me, please. I don't need your texts right now. Bye.